Look up at the night sky. What do you see? A vast, dark canvas sprinkled with twinkling lights. For millennia, humanity has gazed upon these stars, weaving myths, navigating oceans, and pondering our place in the cosmos. But what if I told you that some of the faintest, reddest specks in that cosmic tapestry are not what they seem? What if they are hiding a secret, a story of cosmic giants that defy our understanding of stars? Today, we re-journeying to the edge of the known universe to uncover the mystery of little red dots that might just be monster stars. When we think of the first stars, astronomers have a specific picture in mind. These were the pioneers of the cosmos, born just a few 100 million years after the Big Bang. The universe back then was a very different place. It was filled almost exclusively with hydrogen and helium, the lightest elements forged in the fire of creation without the heavier elements, what astronomers call metals, that we see in stars today. These first-generation stars, known as population 3 stars, could grow to gargantuan sizes. Imagine stars hundreds or even thousands of times more massive than our own sun. These behemoths would have burned incredibly hot and lived fast, furious lives, ending in spectacular explosions that seeded the universe with the first heavy elements. These elements then became the building blocks for the next generation of stars, for planets, and eventually, for us. The problem is, despite their theoretical importance, we've never directly seen a population 3 star. They are simply too far away and lived too long ago. Finding one would be like finding a fossil from the dawn of cosmic time, a direct window into the universe's infancy. So, where do the little red dots come in? This is where the story gets exciting. Thanks to the incredible power of the James Webb Space Telescope, or JWST, we are peering deeper into the universe's past than ever before. JWST is designed to see in infrared light, which is perfect for spotting extremely distant objects. As light travels across the expanding universe, its wavelength gets stretched out, shifting it towards the red end of the spectrum. This is called redshift. The most distant objects are therefore the most redshifted, appearing to us as faint, red smudges. Recently, astronomers using JWST pointed its powerful mirror at a region of the sky and found something puzzling. They identified 4 very distant galaxies, so far away that we are seeing them as they were when the universe was just 300 to 500 million years old. And within these ancient galaxies, they saw sources of light that were odd. They were incredibly bright, yet they didn't look like the sprawling, messy collections of billions of stars we expect from a young galaxy. Instead, they appeared as compact, intensely luminous points of light, little red dots. What could they be? The first and most conventional explanation is that they are simply young, small galaxies in the process of forming. A dense cluster of hot, young stars could, in theory, produce this kind of light. This is the safe answer, the one that fits neatly into our existing models of galaxy formation. It's a plausible explanation, and for some of these objects it might be the right one. But for a few of them, the data just doesn't quite fit. The sheer brightness packed into such a tiny space is hard to explain with a normal star cluster. It would have to be an extraordinarily dense and efficient star-forming region, something beyond what our models typically predict for such an early time. This is where the more spectacular possibility comes into play. What if we're not looking at a collection of thousands of stars, but at one single, colossal object? This is the monster star hypothesis. Or more accurately, a supermassive star. The idea is that one of these little red dots could be a single star, a direct descendant of the legendary population 3 stars, but with a twist. It might be a star that has continued to grow, accreting huge amounts of pristine gas from its surroundings, swelling to a mass millions of times that of our sun. A star that massive is almost beyond comprehension. It wouldn't just be a star, it would be a cosmic furnace of unimaginable power. Its surface temperature would be scorching, and it would radiate with a brilliance that could outshine its entire host galaxy. If this hypothesis is correct, it would mean we have found something truly new, a type of celestial object we only suspected could exist. It bridges the gap between the most massive stars we know and the supermassive black holes that sit at the center of galaxies. Think about it. We know that supermassive black holes, millions or even billions of times the sun's mass, existed very early in the universe. But how did they get so big, so fast? It's one of the biggest puzzles in modern cosmology. One theory is that they grew from the seeds of massive stars. A population 3 star could collapse into a black hole a few hundred times the sun's mass. But growing that into a billion solar mass monster in just a few 100 million years is a real challenge. These potential supermassive stars offer a tantalizing alternative. Instead of forming a star that then collapses into a black hole, what if a huge cloud of gas collapsed directly into a massive black hole, skipping the star phase? Or what if one of these supermassive stars, after its brief but brilliant life, collapsed directly into an intermediate mass black hole, providing a much larger seed for a supermassive black hole to grow from? Finding one of these objects would be a game changer, providing a crucial missing link in the story of how cosmic structures evolve. So, how do we tell the difference? How can astronomers be sure if they're seeing a baby galaxy or a monster star? It all comes down to the light. By carefully analyzing the spectrum of the light from these red dots, scientists can look for clues, A galaxy full of stars will have a specific light signature, a broad spectrum created by millions of different stars at different temperatures. A single supermassive star, on the other hand, would have a much more specific and unique spectrum. Astronomers will be looking for specific spectral lines, like the signature of ionized helium. A star hot and massive enough to be one of these monsters would be pouring out so much high-energy radiation that it would strip electrons from the helium gas around it, creating a distinctive glow that JWST is perfectly tuned to detect. If they find that specific helium signature, and it's coming from a single point source, the case for a supermassive star becomes much, much stronger. The investigation is ongoing. Teams of scientists are poring over the data from JWST, planning new observations to get a closer look at these enigmatic objects. Each new image, each new spectrum, brings us closer to an answer. It's a thrilling moment in astronomy. We are living in an era where we can genuinely probe the cosmic dawn. Regardless of the final answer, the discovery of these little red dots is a triumph. It showcases the incredible capability of our tools and the relentless curiosity that drives science. If they turn out to be nascent galaxies, we will learn invaluable information about how the first cosmic cities of stars were built. We'll refine our models and gain a clearer picture of that chaotic and creative period in our universe's history. But if even one of them turns out to be a supermassive star, it will be a revolution. It would confirm the existence of a new class of celestial object and rewrite our understanding of the early universe. It would be a direct glimpse of the titans that forged the first heavy elements and perhaps planted the seeds for the black hole giants that now govern galaxies. The universe is always more strange and more wonderful than we can imagine. For now, these little red dots remain a profound mystery, a cosmic question mark hanging in the deepest, oldest reaches of space. Are they the cradles of galaxies, or are they the monster stars of cosmic legend? Only time, and more data from our magnificent eye on the universe, will tell. The search continues, and we are all on the front row, waiting for the next postcard from the dawn of time. As we continue to look up, let's remember that even the faintest speck of light has a story to tell. A story that might just change everything we thought we knew about the cosmos. Thanks for joining me on this journey to the edge of time. Don't forget to like and subscribe for more explorations into the wonders of our universe.